Imagine for a moment that you're sitting alone in your room, late at night, scrolling through data that should be nothing but cosmic noise, the random hiss and crackle of the universe doing what it's always done. Then, suddenly, something impossible appears. Something that shouldn't exist. Something that makes your hand freeze, your breath catch, and your mind race with a single, terrifying, exhilarating thought. We are not alone. On August 15, 1977, an astronomer named Jerry Eman experienced exactly this moment. What he saw on that computer printout would become one of the most compelling mysteries in the history of science. A mystery that remains unsolved to this day. It would be called the wow signal, and it would change how we think about our place in the cosmos forever. But here's what keeps scientists awake at night. We heard it once, clear as a bell, impossibly strong, coming from the depths of space. And then, silence. Nothing. Not ever again. So what was it? Did we actually hear aliens in 1977? Or did something else, something we still don't understand, reach out across the void and touch us for exactly 72 seconds before vanishing into the darkness? To understand why the wow signal matters so much, why it haunts the dreams of astronomers and fills the pages of scientific journals even decades later, you need to understand what the night sky really is. When you look up at the stars, you're not just seeing distant suns. You're looking backward through time, seeing light that left those stars thousands, millions, even billions of years ago. You're staring at a universe so vast that our minds can barely comprehend it. A universe containing more stars than all the grains of sand on all the beaches on Earth. And with that incomprehensible vastness comes a question that humanity has asked since we first became conscious enough to wonder. Are we alone? It's a question that cuts to the very heart of what it means to be human. Are we a cosmic accident, a single lonely spark of consciousness in an infinite dark ocean? Or is the universe teeming with life, with civilizations that might be watching us right now, waiting for us to grow up enough to join them? By the 1970s, this question had moved from the realm of philosophy and science fiction into actual science. The search for extraterrestrial intelligence, known as SETI, had become a legitimate field of study. Scientists realized that if intelligent aliens existed and had technology anything like ours, they might be broadcasting radio signals, either intentionally to communicate with other civilizations or unintentionally as a byproduct of their technology, just like we do. And radio waves, unlike light, can travel through the dust and gas of space relatively unimpeded. They can cross the vast distances between stars. All we needed to do was listen. But space is unimaginably huge, and radio frequencies cover a vast spectrum. Where do you point your telescope? What frequency do you listen to? It would be like trying to find one specific conversation in a city of billions of people, all talking at once, in rooms you can't see, in languages you don't know. But scientists had an idea, a frequency that made sense, a channel that any intelligent civilization might choose if they wanted to be heard. 1420 megahertz. The hydrogen line. Hydrogen is the most abundant element in the universe, the simplest atom, consisting of just one proton and one electron. When the electron in a hydrogen atom flips its spin, it emits radiation at exactly this frequency. It's a frequency that the universe itself sings in, a natural tone that any civilization advanced enough to build radio telescopes would inevitably discover. In 1959, physicists Giuseppe Cacconi and Philip Morrison published a paper suggesting that this frequency would be the logical choice for interstellar communication. It was nature's way of saying, listen here. The hydrogen line became known as the cosmic waterhole, a place where different species might gather to meet, just like animals gathering at a waterhole in the African savanna. Think about that for a moment. Across the incomprehensible distances of space, separated by light years and perhaps millennia, two civilizations might independently decide to listen to the same frequency, the universe's own suggestion for where to have a conversation. In Ohio, at the university's radio observatory, a massive radio telescope nicknamed Big Ear was doing exactly that, listening. Big Ear wasn't elegant or sleek like modern observatories. It was a monument to practical engineering, A structure the size of 3 football fields, built from simple materials, metal and wire and electronics, pointed permanently at the sky. As the Earth rotated, different portions of the sky would drift through Big Ear's field of view, like a cosmic carousel bringing new possibilities with each passing moment. The telescope couldn't move, so the universe had to come to it, each section of the night sky given exactly 72 seconds of attention before the Earth's rotation carried it onward. Every day, Big Ear collected data, recording the intensity of radio signals from space across 50 channels simultaneously, printing the results on perforated computer paper in an endless stream of numbers and letters. Most of the time, it recorded nothing but noise, the random static of the cosmos, cosmic background radiation, the echo of the Big Bang itself, distant pulsars, the general electromagnetic chaos of a universe full of natural phenomena. The data was stored, reviewed days later by volunteers who would scan the printouts looking for anything unusual. It was tedious work, looking through columns of numbers representing mostly nothing, day after day, night after night. Jerry Emmon was one of these volunteers. He was a professor, an astronomer, a man dedicated to the patient work of science, the kind of work that rarely produces dramatic discoveries but occasionally, just occasionally, reveals something extraordinary. On August 19, 1977, 4 days after the signal had actually been received, Emmon was at his home reviewing the printouts from Big Ear's observations. Can you imagine it? Sitting at a table, probably with a cup of coffee, going through pages and pages of alphanumeric sequences, each character representing the intensity of a signal on a scale where a space or a low number was normal background noise. One character after another, column after column, nothing, nothing, nothing. And then, his eyes caught something that made no sense. A sequence that stood out like a shout in a silent room. 6EQUJ5. To understand why this was extraordinary, you need to know the code. The intensity of signals was represented by numbers 1 through 9, and then, for anything stronger, by letters. A 1 meant barely anything. A 2, slightly more. By the time you got to letters, you were seeing something unusual. The sequence 6EQJ5 meant the signal started moderately strong, then jumped to E, then Q, then U, then J, then back down to 5. The letter U represented the strongest point, and you meant the signal was 30 times stronger than the background noise. 30 times stronger, from deep space. At a frequency right next to the hydrogen line, the exact frequency an intelligent civilization might use to say, "We're here." The signal had lasted the full 72 seconds that Big Ear observed that portion of the sky, rising smoothly to maximum intensity and then falling away, exactly as you'd expect from a distant point source of radio waves as the Earth's rotation carried the telescope's focus across it. Emmon grabbed his red pen and circled the sequence. Next to it, expressing the shock, the excitement, the disbelief that any scientist would feel at this moment, he wrote one word: "Wow!" He didn't write "alien signal detected" or "possible extraterrestrial contact." He wrote what any of us would write when confronted with something that seemed impossible but was right there on the paper in front of him. Wow. Just wow. That single word would give the signal its name and capture the imagination of the world. But here's where the story becomes both more fascinating and more frustrating. Emmon and his colleagues immediately understood what they had. They knew this could be the most important discovery in human history. They also knew they had to be careful, that extraordinary claims require extraordinary evidence, that science demands skepticism and verification. The first rule of discovering something amazing is to make sure it's actually real. So they looked for the signal again. Big Ear turned its attention back to that exact same spot in the sky, in the constellation Sagittarius, near the star cluster M55, coordinates precisely recorded from the moment of detection. They listened. They heard nothing. They listened again. Nothing. They listened more than 50 times over the following months and years. They pointed other radio telescopes at the same location. Nothing. The signal had appeared once, perfect and impossible and clear, and then vanished as if it had never existed. How do you investigate something that won't repeat? How do you study a ghost? Let me ask you something to think about. If you heard a voice call your name once, clearly, unmistakably, but when you turned around no one was there, and you never heard it again, what would you believe? Would you trust your senses, certain you heard something real? Would you dismiss it as imagination, a trick of the mind? Would you spend the rest of your life wondering? This is the position scientists found themselves in with the WOW signal. They had hard data, a physical printout, evidence that something had been detected. But the cornerstone of the scientific method is repeatability. An experiment must be reproducible. An observation must be verifiable. The WOW signal was neither, and that made it scientifically maddening. It was real enough to be compelling, but elusive enough to remain forever uncertain. The location the signal came from is significant. Sagittarius lies in the direction of the center of our galaxy, a region dense with stars, a place where, statistically, life might be more likely if only because there are more stars, more planets, more chances for chemistry to do something extraordinary. The signal's apparent origin was far from the ecliptic plane, the flat disk of our solar system where our planets orbit, making it less likely to be interference from human satellites or space probes. It came from a direction in the sky that suggested deep space, something far beyond our solar system, perhaps far beyond our local stellar neighborhood. When astronomers calculated the possible distance based on the signal's strength, they realized that if this was a broadcast from an alien civilization, it would have to be extraordinarily powerful. We're talking about a civilization capable of beaming radio signals across interstellar space with enough intensity that they could be detected across light years of distance. This wouldn't be an accidental signal, like our television broadcasts leaking into space. This would be intentional, a beacon, a deliberate shout into the cosmos saying, "We exist." But let's think about what this means. If the WOW signal was aliens, they would have been broadcasting from a distance of perhaps dozens, or even hundreds of light years away. Light years. Do you grasp what that means? A light year is the distance light travels in 1 year, moving at 186,000 miles per second, covering nearly 6 trillion miles in a single year. Even the nearest star to our Sun, Proxima Centauri, is over 4 light years away. If the WOW signal came from a civilization 100 light years distant, the signal we received in 1977 was broadcast in 1877. Think about Earth in 1877. The telephone had just been invented. Edison was working on the light bulb. Radio wouldn't be discovered for another decade. While our great-great-grandparents were riding horses and lighting candles, a civilization 100 light years away might have been beaming a message into space that would take a century to reach us. And here's the truly unsettling part. If we sent a reply today, and if they're still there, still listening, they wouldn't receive our response until 2177, 200 years after the original signal. That's the scale of interstellar communication. That's the patience it would require. That's why the signal, if it was aliens, would represent not just intelligence but a commitment to communication across timescales that dwarf human civilizations. The scientific community's response to the WOW signal was a mixture of excitement, extreme caution, and intense scrutiny. This is exactly as it should be. Science doesn't work by accepting extraordinary claims without extraordinary evidence. The history of science is littered with observations that seemed revolutionary but turned out to be instrumental errors, misinterpretations, or natural phenomena we didn't yet understand. Pulsars, when first discovered in 1967, were briefly labeled LGM-1 for little green men because their regular pulses seemed almost artificial. They turned out to be rapidly rotating neutron stars, exotic and fascinating, but entirely natural. Scientists had to consider every possible explanation for the WOW signal before even entertaining the alien hypothesis. Could it have been a satellite? Unlikely, given the signal's frequency, strength, and the fact that it appeared to come from deep space, and its narrow bandwidth. Human satellites tend to broadcast across wider frequency ranges and would have moved across the sky, causing the signal to drift in frequency due to the Doppler effect. The WOW signal showed no such drift. It remained at a constant frequency, suggesting a source that wasn't moving relative to Earth, or was so distant that its motion was negligible. Could it have been a secret military transmission? Again, unlikely. The frequency was close to the hydrogen line, a region of the spectrum that's actually protected for radio astronomy by international agreement precisely because it's so important for scientific observation. Broadcasting on this frequency would violate those agreements, and military communications typically use very different frequencies and encoding methods. Moreover, the signal's characteristics, its strength, duration, and behavior, didn't match known human transmission patterns. Could it have been an error in the equipment, a glitch in Big Ear's electronics or computer systems? This was thoroughly investigated. The Big Ear telescope had been operating for years, collecting data continuously, and had never produced anything like this before or after. The signal appeared on only one of the 50 channels Big Ear monitored simultaneously, exactly the channel you'd expect if a real signal was coming from space at that frequency. If it had been an electrical problem or computer error, you'd expect it to show up across multiple channels or to have happened more than once. The signal's characteristics, the smooth rise and fall in intensity over 72 seconds, perfectly matched what you'd expect from a real point source of radio waves passing through the telescope's beam as the Earth rotated. Everything about it looked legitimate. Could it have been some natural cosmic phenomenon, something we don't fully understand? This is possible, and it's the explanation many conservative scientists favor when pressed. The universe is full of things that generate radio waves. Pulsars, quasars, masers, flare stars, all sorts of energetic events produce radio emissions. But the WOW signal didn't match the profile of any known natural source. Natural sources tend to either broadcast across a wide range of frequencies or, if they're narrowband, they repeat with some regularity. The WOW signal was remarkably narrowband, concentrated in a tiny sliver of the radio spectrum, just like an artificial signal would be. And it appeared once, never to repeat, which isn't how natural cosmic sources typically behave. Pulsars pulse. Masers might vary, but they don't just appear for 72 seconds and disappear forever. The signal's characteristics kept bringing scientists back to one uncomfortable possibility. It was artificial. Someone or something had generated it deliberately. Now, here's where the human element of this story becomes so poignant. Jerry Emmon, the man who discovered the WOW signal, spent the rest of his life fielding questions about it. He was careful, always careful, to say he didn't know what it was. He never claimed it was aliens. He never said it was definitely extraterrestrial intelligence. But he also never dismissed the possibility. In interviews over the years, he maintained that the signal was, at the very least, worthy of further investigation, that it represented something genuinely anomalous, something that didn't fit neatly into our understanding of the cosmos. He said that while the signal was consistent with an extraterrestrial origin, he couldn't say for certain without more data, without a repeat detection. He embodied the scientific ideal, open-minded but demanding evidence, willing to consider extraordinary possibilities but not willing to make extraordinary claims without extraordinary proof. He died in 2022, 45 years after discovering the signal, without ever knowing for certain what it was. Think about that. Imagine making potentially the most important discovery in human history and never knowing if that's actually what you did. Imagine carrying that uncertainty with you for 45 years. Would it haunt you? Thrill you? Both. Let's talk about why the frequency of the WOW signal matters so much, because this detail is crucial to understanding why scientists took it so seriously. The signal was detected at 1420.456 MHz, incredibly close to the hydrogen line at 1420.406 MHz. This is not random. This is the cosmic water hole I mentioned earlier, and the more you understand about it, the more significant it becomes. Hydrogen atoms in space, when their electron flips from one spin state to another, emit photons at this specific frequency. This emission line is one of the most important tools in astronomy. It allows us to map the distribution of hydrogen throughout the universe, to track the rotation of galaxies, to probe the structure of the cosmos. Every radio astronomer in the universe, human or alien, would know about this frequency because it's fundamental to understanding the universe around them. If you wanted to send a signal that other technological civilizations would notice, you choose a frequency that you know they'd be monitoring, and the hydrogen line is the most obvious choice. It's the universe's own billboard, saying, "Advertise here." But there's more. The region around the hydrogen line, from about 1400 to 1600 megahertz, is relatively quiet in terms of natural radio noise. It's a window of relative silence in the electromagnetic spectrum, making it ideal for communication because signals would stand out clearly against the background. This window also includes the emission line of hydroxyl, OH, at 1612 megahertz. Hydrogen, H, plus hydroxyl, OH, equals water, H2O. This region of the spectrum, between the hydrogen and hydroxyl lines, is called the cosmic water hole, and it's where SETI researchers have concentrated much of their search efforts. It's the place where, metaphorically speaking, different species in the cosmic savanna might gather to communicate. The fact that the WOW signal appeared almost exactly at the hydrogen line suggests, though doesn't prove, that whoever or whatever generated it understood this logic. It suggests intentionality. It suggests intelligence. For years, decades even, the WOW signal remained a tantalizing mystery, one of those scientific curiosities that people debate at conferences and write papers about, always with the caveat that we simply don't have enough information. Then, in 2016, something happened that many people thought closed the case. Antonio Paris, a professor at St. Petersburg College in Florida, proposed a new explanation. He suggested that the signal could have been caused by a comet. Not just any comet, but specifically one that wasn't even discovered until after the WOW signal was detected. On January 27, 2006, Comet 266P Christensen was discovered. Its orbit was calculated backward, and Paris realized that in August 1977, this comet had been in the same region of the sky where the WOW signal originated. Comets, Paris argued, are surrounded by massive clouds of hydrogen gas, which could potentially emit radio signals at the hydrogen line frequency. He proposed testing this hypothesis by observing other comets and seeing if they produced similar signals. In 2017, Paris published his results. He claimed that he had observed comets 266P Christensen and P2008Y2 Gibbs with a radio telescope and detected emissions at 1420 MHz, the hydrogen line. He argued that this supported his hypothesis and that the WOW signal was most likely caused by comets, not aliens. The media, always eager for definitive answers to mysteries, largely reported this as mystery solved. WOW signal was just a comet. The story was picked up by major news outlets, and for many people, that was the end of it. Case closed. It was a comet, not aliens. Just a natural phenomenon we hadn't considered. But here's the thing. Science doesn't work by press release. Science works by peer review, by replication, by scrutiny. And when other scientists looked closely at Paris's work, they found significant problems. First, several astronomers pointed out that Paris's detection of radio emissions from comets was not actually at 1420 MHz. His own data showed emissions at frequencies offset from the hydrogen line, not directly on it, which is what you'd expect from the Doppler shift of the comet's movement. The WOW signal, in contrast, was detected right at the hydrogen line with no Doppler shift, suggesting the source wasn't moving toward or away from Earth at any significant speed. Second, other research groups who observed comets with radio telescopes didn't detect the strong emissions that Paris reported. In fact, a team led by Jim Benford, a plasma physicist who has worked extensively on SETI, specifically observed Comet Christensen and reported that while they detected some radio emissions, these were far too weak to account for the WOW signal. They calculated that the signal strength from the comet's hydrogen cloud would be thousands of times weaker than what Big Ear detected. Third, several independent astronomers noted that if comets routinely produced signals as strong as the WOW signal, we'd have detected many such signals over the decades of radio astronomy observations. Big Ear alone operated for more than 20 years, observing the sky continuously, and never detected another signal like WOW. If comets were the explanation, this would be extraordinarily unlikely. Fourth, and this is particularly damning for the comet hypothesis, another comet was also in Big Ear's field of view at the time of the WOW signal. If comets produced such strong signals, why didn't this second comet also produce a detection? The Big Ear telescope observed a fairly wide area of sky, and if one comet produced the WOW signal, a second comet in the same region should have produced something similar. It didn't. Finally, professional SETI researchers and radio astronomers pointed out that the characteristics of the WOW signal, its extremely narrow bandwidth and its consistent frequency, don't match what we'd expect from a natural source like a comet. Natural emissions tend to be broader in frequency range. The WOW signal was extraordinarily focused, less than 10 kilohertz wide in a region of the spectrum billions of hertz across. That kind of narrowband transmission is a hallmark of artificial signals. So while the comet hypothesis got a lot of media attention, the scientific community largely didn't accept it as a definitive explanation. The mystery remained open. Let me ask you to consider something. Why do we want the WOW signal to have a mundane explanation? Is it because we're skeptical by nature, trained to seek the simplest explanation? Or is it because the alternative is too profound, too unsettling, too transformative to accept without absolute proof? The idea that we might have detected an alien signal, even once, changes everything. It means we're not alone. It means that somewhere out there, someone else looked up at their sky, wondered the same questions we wonder, built technology, created civilization, and deliberately sent a message into the cosmos. It means the universe isn't empty. It means that consciousness, intelligence, the ability to ponder existence, isn't unique to Earth. This is either the most wonderful or the most terrifying realization in human history, depending on your perspective. And maybe that's why we instinctively reach for explanations that let us keep the universe familiar, manageable, empty except for us. But what if we're wrong to do that? What if our skepticism, healthy and necessary as it is, causes us to dismiss something genuine? The history of science includes moments when the establishment rejected ideas that turned out to be true because they seemed too extraordinary. Continental drift, the idea that Earth's continents move, was dismissed for decades because it seemed impossible. The existence of meteorites, rocks falling from the sky, was denied by the French Academy of Sciences in the 18th century because scholars believed the sky couldn't possibly contain rocks. We later learned we were wrong. So when we say the WOW signal probably wasn't aliens, probably has some natural explanation we just haven't figured out yet, are we being appropriately skeptical, or are we being reflexively dismissive? I'm not suggesting we should believe it was aliens without evidence. I'm asking whether our threshold for accepting such evidence might be unreasonably high, whether we might be so committed to the idea that we're alone that we dismiss genuine contact because it doesn't repeat on our schedule, doesn't conform to our expectations, doesn't persist long enough to satisfy our need for certainty. Let's explore what happens if we take the alien hypothesis seriously, not as proven fact, but as a genuine possibility worth considering. If the WOW signal was a deliberate transmission from an extraterrestrial civilization, what might that tell us? First, it tells us the civilization is or was capable of generating extremely powerful radio transmissions. The signal we detected was strong, remarkably so, which means the source had to be either relatively close by cosmic standards, within a few hundred light-years perhaps, or incredibly powerful, capable of beaming signals across thousands of light-years. This suggests a civilization with significant technological capabilities, far beyond our own current abilities for interstellar communication. We can barely send coherent signals to the edge of our own solar system. They would have been broadcasting across interstellar space with enough power to be detected by a relatively primitive radio telescope like Big Ear. Second, The choice of frequency suggests they understand physics and astronomy well enough to know that the hydrogen line is significant, that other technological civilizations would monitor this frequency. This implies not just technology but scientific sophistication, an understanding of what makes sense for interstellar communication. Third, and this is fascinating, the fact that we only heard it once might actually be meaningful. Think about it. If you wanted to send a message to unknown civilizations scattered across the galaxy, you wouldn't just beam a signal in one direction continuously. That would be inefficient. You'd sweep the galaxy, broadcasting toward different star systems, giving each a moment of attention before moving on. Like a lighthouse sweeping its beam across the ocean, you'd give each potential listener a brief flash of signal, enough to be detected, enough to say, "We're here," before moving to the next target. The 72-second duration of the WOW signal matches almost perfectly the length of time that Big Ear's beam would observe any given point in the sky due to Earth's rotation. It's as if the transmission was designed to be detectable for exactly that duration, or as if we caught the tail end of a beam sweeping past us. If this interpretation is correct, the signal might still be out there, still sweeping the galaxy, broadcasting to other star systems, other potential civilizations, while we sit here wondering if we'll ever hear it again. Fourth, there's the question of intent. Was this a deliberate message to us specifically? Almost certainly not. If a civilization 100 light-years away detected our presence, detected our radio transmissions or some sign that we exist, and sent a targeted message, it wouldn't arrive for 100 years. The WOW signal came from a direction in space where we hadn't sent any signals strong enough to be detected at interstellar distances. So if it was aliens, it was probably a general beacon, a signal sent to no one in particular and everyone in general, a message saying, any intelligent species capable of building a radio telescope, we're here, you're not alone. Think about the philosophy behind that. Think about a civilization that decides to spend energy and resources broadcasting into space, not knowing if anyone is listening, not knowing if anyone will ever hear, not even knowing if anyone else exists. That's an act of hope, isn't it? Or perhaps an act of loneliness. It's a message in a bottle thrown into an infinite cosmic ocean, with no guarantee it will ever be found, but a commitment to trying anyway because the alternative, silence, is unbearable. Now let's consider the opposite. Let's rigorously explore the possibility that the WOW signal wasn't aliens, that it has some explanation we either haven't discovered or haven't properly understood. This is the position most scientists take, not because they're closed-minded, but because the evidence, while intriguing, isn't conclusive. In science, when you can't reproduce a result, when you can't verify an observation, it remains questionable. The WOW signal appeared once. Every attempt to find it again has failed. This doesn't necessarily mean it wasn't real, but it does mean we can't study it, can't analyze it further, can't rule out alternative explanations with certainty. There are several possibilities that don't involve aliens. One is that it was some form of terrestrial interference that somehow made it past the various filters and safeguards designed to exclude such signals. Perhaps a brief, unusual reflection of a terrestrial signal off some object in space, like a piece of space debris or an asteroid, that created the appearance of a signal coming from deep space. This seems unlikely given the signal's characteristics, but unlikely isn't the same as impossible. Another possibility is that it was caused by a rare, not yet understood astrophysical phenomenon. The universe is a strange place full of things we're still learning about. We've discovered fast radio bursts, brief intense pulses of radio emission from distant galaxies, only in the last couple of decades. Before we knew what they were, any single detection might have seemed inexplicable. Perhaps the WOW signal was something similar, a phenomenon that happens rarely, that we don't yet have the data to identify and categorize. This hypothesis has the advantage of being testable, at least in principle. As we build more sensitive radio telescopes and observe more of the universe, we might eventually detect similar signals and come to understand what causes them. The challenge is that rare events are, by definition, hard to study. If something happens once every few decades, randomly, anywhere in the sky, Detecting it even twice becomes a matter of luck as much as diligence. Then there's the possibility that has probably occurred to you. What if we're looking in the wrong place or at the wrong time? Suppose the signal does repeat, but on a time scale we haven't properly monitored. Maybe it broadcasts once every year or once every decade, and we just haven't been watching that exact spot at the exact right time to catch it again. Big Ear continued to operate for years after the WOW signal, but it didn't continuously monitor that one specific location. It swept the sky as Earth rotated, observing each point for 72 seconds and then moving on. If the signal had appeared again 6 hours later, or a week later, or during daylight hours when observations weren't being conducted, it would have been missed. This possibility is both hopeful and frustrating. Hopeful because it means the signal might still be out there, waiting to be found again. Frustrating because the amount of time and resources required to continuously monitor every potentially interesting location in the sky is staggering, perhaps beyond our current capabilities. Let's talk about the silence that followed the WOW signal, because this silence is almost as significant as the signal itself. In the 40-plus years since that August night in 1977, we've built bigger radio telescopes, more sensitive equipment, and more sophisticated data analysis systems. We've scanned the skies with the Arecibo telescope, may it rest in peace after its collapse in 2020, with the Green Bank telescope, with a very large array, with radio observatories around the world. SETI has evolved from a handful of researchers to an international effort involving organizations like the SETI Institute, Breakthrough Listen, and others, using cutting-edge technology to search for signs of extraterrestrial intelligence. We've examined millions of stars, analyzed billions of radio signals, and processed incomprehensible amounts of data. And in all that searching, we haven't found another signal like WOW. We found pulsars and quasars and fast radio bursts and all manner of cosmic phenomena. We've even found a few interesting signals that got people excited before being explained as satellites or terrestrial interference. But nothing like WOW. Nothing with that combination of characteristics, that strength, that tantalizing possibility. What does this silence mean? The pessimistic interpretation is that the WOW signal was never what we hoped, that it was some kind of fluke, an error, a misunderstanding, and we're alone in the universe after all, shouting into the void with no one to answer. The optimistic interpretation is that the universe is vast, communication is hard, and we've barely begun to search. Think about the numbers. Our galaxy contains somewhere between 100 billion and 400 billion stars. We've examined a tiny fraction of them, and only at certain frequencies, at certain times, with equipment that, while impressive, is still primitive by the standards of what might be possible. If advanced civilizations are rare, scattered across the galaxy with thousands of light years between them, the chances of us detecting their signals are incredibly small. We might need to search for centuries before finding something definitive. The silence doesn't necessarily mean no one is there. It might just mean we haven't listened long enough, haven't looked in the right places, haven't developed sensitive enough ears to hear the whispers crossing the interstellar dark. There's also a darker possibility that's worth considering, one that relates to something called the Fermi paradox. Enrico Fermi was a physicist who, during a lunch conversation in 1950, asked a simple question that has haunted scientists ever since. Where is everybody? If the universe is so vast, if there are so many stars and planets, if intelligent life can arise, then even if it's rare, there should be millions of civilizations out there. Some of them should be millions or billions of years older than us, with technology so advanced we couldn't begin to comprehend it. They should have colonized the galaxy by now. We should see signs of them everywhere. So where are they? Why is the universe so quiet? One possible answer, a chilling one, is that civilizations don't last. Maybe something happens to technological civilizations, something that happens reliably enough that the galaxy isn't full of them. Maybe they destroy themselves through war or environmental catastrophe. Maybe they create artificial intelligence that replaces them or technologies they can't control. Maybe there's some natural phenomenon, something we don't know about yet, that ends civilizations before they can spread to the stars. If this is true, the wow signal becomes even more poignant. It might be a voice from a civilization that's already gone, a ghost calling across the light years from a world that no longer exists. Or perhaps civilizations do survive, but they stop broadcasting. Think about our own technological development. We've been leaking radio signals into space for about 100 years, but modern communications technology is moving toward efficiency, toward focus beams, fiber optics, spread spectrum transmissions that look like noise unless you know how to decode them. Our accidental radio signature is actually getting quieter, not louder. In another century, an alien astronomer pointing a telescope at Earth might detect nothing but natural radio emissions, unaware that a technological civilization lives here. If other civilizations follow a similar path, there might be a brief window, perhaps only a century or two, when a civilization is detectable through its radio emissions. Before that window, they haven't developed radio yet. After that window, they've moved on to quieter technologies. The galaxy might be full of civilizations we can't detect because they're either not advanced enough yet or too advanced to be loud. The wow signal, in this scenario, might have been our luck, our chance alignment with another civilization's brief window of detectability, a moment when their technology and ours overlap just enough for us to hear a whisper across the void. Let me pose a question for you to reflect on. If we definitively prove tomorrow that the wow signal was just a comet, or interference, or some natural phenomenon, would you be relieved or disappointed? Think about that honestly. There's a part of us that wants to know we're alone, that the universe is ours to explore, that we don't have to worry about other intelligences with unknowable intentions and incomprehensible capabilities. There's a comfort in loneliness, in uniqueness, in being the only ones who matter. But there's also a part of us that desperately wants to know we're not alone, that consciousness and intelligence and the ability to wonder about the universe aren't cosmic accidents unique to one small planet, that somewhere out there, someone else is looking up at the stars and asking the same questions we ask. The wow signal sits at the intersection of these two desires, evidence enough to hope but not enough to know, a Rorschach test revealing what we want to believe about our place in the cosmos. The cultural impact of the wow signal extends far beyond scientific papers and radio astronomy conferences. It's become an icon of the search for extraterrestrial intelligence, a symbol of both the promise and the frustration of that search. It appears in documentaries, books, science fiction stories, songs, and artwork. It represents the tantalizing possibility that we might have already heard from aliens, that contact might have already happened, however briefly, however ambiguously. In 2012, on the 35th anniversary of the wow signal's detection, a response was sent from the Arecibo telescope in Puerto Rico. A collection of videos, images, and messages from the public was transmitted toward the same region of space the signal came from. A symbolic gesture acknowledging that even if we don't know what the signal was, we're responding to the possibility that someone might be listening. The transmission will take decades to reach the target region, and if anyone is there, and if they respond, their reply won't arrive until the 21st century is well advanced. Perhaps not until the next century. This is the pace of interstellar conversation. Generations passing between message and reply. Artists have been particularly drawn to the wow signal. There's something aesthetically powerful about it, about the image of that computer printout with the circled characters and the handwritten "wow" in red pen. It's become an image immediately recognizable to anyone interested in SETI, a visual representation of the moment when the universe might have spoken to us. Musicians have incorporated the signal's data into compositions, translating the intensity values into notes or rhythms, creating music from what might be an alien transmission. Filmmakers use it as a reference point, a real-world example that lends credibility to stories about contact with extraterrestrial intelligence. In this way, the wow signal has transcended its origins as a scientific anomaly and become part of our cultural mythology, a modern mystery that captures the imagination the way ancient mysteries did for our ancestors. But let's return to the science, because there are aspects of the wow signal that deserve deeper examination. One of the most puzzling features is how precisely it matched the expected profile of a point source. As I mentioned earlier, The signal's intensity rose and fell over 72 seconds in a pattern that perfectly matched what you'd expect from a radio source at a fixed location in space as Earth's rotation carried the telescope's beam across it. This is called the antenna pattern, and it's determined by the shape and size of the telescope. Big Ear's beam was roughly shaped like an elongated oval, and as that beam swept across a point source, you'd see the signal start weak, strengthen as the source moved toward the center of the beam, reach maximum intensity at the center, then weaken again as the source moved out the other side. The WOW signal did exactly this. The sequence 6EQUJ5 represents this rise and fall. It started at moderate intensity, rose to maximum at the letter U, then fell back down. This behavior is one of the strongest pieces of evidence that the signal was real, not an artifact or error. Equipment glitches don't typically produce patterns that perfectly match theoretical predictions. They produce noise, spikes, random fluctuations. The WOW signal was too perfect, too precisely what you'd expect from a real signal source. Another significant detail is the signal's bandwidth. Radio signals have width in frequency space. A perfectly narrow signal, one at exactly one frequency with zero width, is actually impossible in nature due to the uncertainty principle and other fundamental physics. But signals can be very narrow, and the narrower they are, the more information that tells us about their source. Natural cosmic sources tend to produce relatively broadband emissions, spreading across a range of frequencies. Artificial signals, especially those designed for communication, are typically narrowband because concentrating your transmission power into a narrow frequency range makes it easier to detect across long distances. The WOW signal was very narrow, estimated at less than 10 kHz wide. In the context of the radio spectrum, which extends across billions of hertz, 10 kHz is incredibly focused. It's like hearing a single pure musical note in a cacophony of noise. This narrowband characteristic is one of the main reasons the signal looked artificial. The signal also appeared on only one of Big Ear's two feed horns. Big Ear's design was unusual in that it had two separate receivers observing slightly different patches of sky simultaneously, with one trailing the other by a few minutes as the Earth rotated. If a source was real and remained in that location in the sky, it should have been detected by the first feed horn and then, a few minutes later, by the second feed horn as the Earth's rotation brought it into the second feed horn's view. The WOW signal appeared on only one feed horn, not the second. This is anomalous and has fueled speculation that either the source was moving, which would be strange for something appearing to come from deep space, or that it simply stopped broadcasting in the few minutes between the first and second observation. If it was a beacon sweeping across the galaxy, this might make sense. We caught the beam during one feed horn's observation, and by the time the second feed horn was in position, the beam had swept past us, moved on to point somewhere else. But this remains speculation. We don't know why it didn't appear on both feed horns, and this aspect of the observation has been used both to argue that the signal might have been terrestrial interference, and to argue that it represents something genuinely unusual and worth investigating further. Let's consider what we've learned about the universe since 1977 and how that knowledge changes our perspective on the WOW signal. In 1977, we didn't know for certain that planets orbited other stars. We assumed they must, based on our understanding of planetary formation, but we had never detected an exoplanet. It wasn't until 1992 that the first confirmed exoplanets were discovered, orbiting a pulsar, and 1995 when the first planet around a sun-like star was found. Since then, we've discovered thousands of exoplanets. We now know that planets are common, that most stars have them, that the galaxy is filled with worlds. We've found planets in the habitable zone, the region around a star where liquid water could exist on a planet's surface. We've found planets similar in size to Earth. We've found planets orbiting in systems nothing like our solar system, hot Jupiters orbiting closer to their stars than Mercury orbits our Sun, planets orbiting binary stars, systems that challenge our assumptions about what's possible. This explosion of knowledge tells us that the raw materials for life, planets and water and organic chemistry, are abundant in the universe. It makes the possibility of life elsewhere seem not just possible but likely. perhaps even inevitable given enough time and enough planets. We've also learned that life on Earth is far more resilient and versatile than we once thought. We've found organisms living in boiling hot springs, in acidic lakes, miles underground in solid rock, in the frozen wastes of Antarctica, in the crushing pressure of the deepest ocean trenches. We've found life thriving in conditions that would have seemed impossible a few decades ago. This science, called extremophile biology, has expanded our understanding of where and how life can exist. It suggests that habitable doesn't mean Earth-like. It means any place where liquid water exists, where there's an energy source, where chemistry can do its work. That could include the subsurface oceans of Jupiter's moon Europa, or Saturn's moon Enceladus, or exoplanets orbiting red dwarf stars, bathed in radiation we consider lethal but which life might adapt to. The universe of possible habitats has grown enormously, which means the universe of possible homes for life has grown too. Every discovery that expands the range of conditions where life can exist makes the existence of extraterrestrial life more plausible, and the existence of extraterrestrial intelligence, while still speculative, more possible. At the same time, we've gained a sobering appreciation for the challenges facing any civilization trying to communicate across interstellar distances. The distances are so vast. The nearest star is over 4 light-years away. The nearest star system that might have a habitable planet is probably farther. Even at the speed of light, the fastest speed possible according to physics as we understand it, it would take years for a signal to cross even these relatively short distances. Crossing the galaxy would take tens of thousands of years. And radio signals weaken as they travel. They spread out, their energy diluting across the expanding sphere of space they cross, following the inverse square law. A signal that's powerful at the source becomes vanishingly weak by the time it's traveled hundreds or thousands of light years. Detecting such a signal requires enormous antennas, incredibly sensitive receivers, sophisticated signal processing to pull a whisper of meaning from an ocean of noise. We can do this now, to some degree, but just barely. The WOW signal, if it was from a distant civilization, would have required either truly immense transmission power or a source relatively nearby, within a few hundred light years at most. This brings us to a fascinating question. If there are other civilizations out there, and if they're trying to communicate, why would they bother? What's the motivation for civilization to spend enormous resources broadcasting signals into space when the chances of success are so small and the timescales are so long? Why would they do it? One answer is the same reason we do it: curiosity and hope. Despite the odds, despite the distances, despite the likelihood that we might never hear a reply, we broadcast messages into space because the possibility of contact, of knowing we're not alone, is too compelling to ignore. The Arecibo message was broadcast in 1974 toward the globular cluster M13, containing hundreds of thousands of stars. That message won't arrive for 25,000 years, and if anyone responds, we won't hear it for 50,000 years. No human alive today will ever know if it was received. But we sent it anyway, as an act of hope, as a statement that we exist and we're reaching out. Perhaps other civilizations feel the same impulse, the same need to say, we're here, even if the reply takes millennia. Another possibility is that advanced civilizations broadcast not expecting replies but as a service to younger civilizations. Think about it. If you're a civilization millions of years old, with technology and knowledge we can't imagine, you might see it as your responsibility, or simply your choice, to help younger species, to let them know they're not alone, to provide guidance or information. A sufficiently advanced civilization might set up beacons throughout the galaxy, automated systems that broadcast continuously for millions of years, saying, here's some useful information, here's how to avoid the mistakes we made, here's proof that survival is possible, you're not alone. Such beacons wouldn't expect or need replies. They'd be gifts to the future, to civilizations that don't exist yet, that might not exist for millions of years, but that might someday emerge, look to the stars, and need to hear a friendly voice. Could the WOW signal have been something like that? A beacon we stumbled across, not a message to us specifically, but a message to anyone, anywhere, who might be listening. There's also the possibility, less comforting but worth considering, that signals like the WOW signal aren't meant for communication at all. They might be byproducts of some other activity, something a civilization is doing for their own purposes that happens to generate detectable radio emissions. We leak radio signals into space constantly as a side effect of our technology. An alien civilization millions of years in advance of us might be doing things, using technologies we can't even conceive of, that produce radio emissions as an incidental effect. They might not even be aware they're broadcasting, or the signal might be some kind of propulsion system, or power generation system, or scientific experiment, something not intended as communication but detectable nonetheless. In this scenario, finding such a signal would still be enormously significant because it would prove the existence of technological civilizations, even if it wasn't a deliberate attempt to say hello. But it would also mean that trying to interpret the signal as a message might be futile. It might not contain information. It might just be noise, the cosmic equivalent of hearing someone's music through an apartment wall, sound without meaning, proof of presence but not communication. Let's talk about the modern search for extraterrestrial intelligence and where the WOW signal fits into the broader effort. SETI today is more sophisticated, more comprehensive, and better funded than it was in 1977, though it still operates on a shoestring budget compared to other scientific endeavors. Organizations like the SETI Institute, Breakthrough Listen, and others are using advanced telescopes and signal processing techniques to scan millions of stars across a wide range of frequencies. Breakthrough Listen, funded by the billionaire Yuri Milner and launched in 2015, is the most comprehensive SETI effort ever undertaken, using some of the world's most powerful telescopes and processing more data per day than all previous SETI efforts combined. They've examined thousands of nearby stars, looking for any hint of artificial signals. So far, nothing definitive, though they found several interesting signals that required follow-up observation before being ruled out as terrestrial interference. Modern SETI searches have learned from the WOW signal. One of the key lessons is the importance of immediate follow-up. When Big Ear detected the WOW signal, days passed before anyone reviewed the data and realized what they had. By that time, Earth's rotation had carried that region of the sky out of view, and they had to wait to observe it again. Modern SETI systems often include real-time analysis and automated alerts. When something interesting is detected, other telescopes can be pointed at the same location within minutes or hours, trying to catch the signal while it's still active. This rapid response capability is crucial because, as the WOW signal demonstrated, interesting signals might not repeat. If you don't catch them immediately, they might vanish forever. This is one reason why modern SETI efforts involve networks of telescopes rather than single instruments. If one telescope detects something, others can immediately verify it, ruling out local interference and confirming that the signal really is coming from space. Another lesson from the WOW signal is the importance of frequency coverage. The original SETI searches, including Big Ear's observations, looked at a relatively narrow range of frequencies, focusing on the hydrogen line and nearby frequencies. Modern searches cover much broader ranges, recognizing that we don't actually know what frequency aliens might use. While the hydrogen line makes logical sense, an alien civilization might think differently, might choose a different frequency for reasons we don't understand. Breakthrough Listen observes across billions of individual frequency channels simultaneously, casting a much wider net. They're also looking for different types of signals. Narrowband continuous waves like the WOW signal, but also brief pulses, modulated signals, signals that drift in frequency, signals that repeat on regular intervals. We're trying not to assume too much about what an alien signal might look like, recognizing that our assumptions might be wrong, that intelligence might manifest in ways we don't expect. There's also growing interest in optical SETI, looking for brief flashes of laser light rather than radio waves. A powerful laser can, in principle, outshine a star for a brief moment when viewed from a narrow angle, and a civilization might use lasers for interstellar communication or even for propulsion systems. Some SETI searches now include optical telescopes equipped to detect nanosecond duration light pulses that might represent alien laser transmissions. This diversification of search strategies reflects a mature understanding that we're looking for something we've never seen before, that we need to be open to multiple possibilities, that the universe might surprise us in ways we haven't anticipated. The WOW signal remains a touchstone for these efforts, a reminder of why we keep searching despite the silence, despite the odds, despite decades without another detection as compelling. Now, let's explore some of the more speculative and fascinating theories about what the WOW signal might represent. These are not mainstream scientific hypotheses, but they're worth considering as possibilities, as thought experiments that stretch our imagination and help us think about the WOW signal from different angles. One intriguing idea is that the signal was a targeted message, not a general beacon. This would require that whoever sent it knew we were here and knew we were capable of detecting radio signals. How could they know? Well, Earth has been leaking radio and television broadcasts into space since the early 20th century. An expanding bubble of electromagnetic noise now over 100 light-years in radius, propagating outward at the speed of light. Any civilization within that bubble, with sufficiently sensitive equipment, could detect our presence. They could know that a technological civilization exists on Earth. If such a civilization, perhaps 50 or 75 light-years away, detected our earliest radio transmissions in the early 20th century and responded, their reply would arrive around now, within decades of when we'd expected. The timing is intriguing. The WOW signal arrived in 1977, roughly 50 to 75 years after our most powerful early radio transmissions. Could it have been a reply, a response to the inadvertent announcement of our presence? This is speculation, but it's speculation that fits the timeline. Another speculative idea involves the possibility of a probe rather than a distant transmission. What if the WOW signal didn't come from a distant star system but from something much closer, an automated probe sent by an alien civilization to explore the galaxy? Such a probe could be in our solar system or passing nearby, and it might have transmitted a brief signal when it detected our presence or for some other reason related to its mission. This would explain why the signal was so strong, why it appeared once and never repeated, and why it seemed to come from a specific location that happened to be in the direction of Sagittarius. If a probe was moving through space, it could have been in that direction relative to Earth in 1977 but has since moved elsewhere, which would explain why we can't find the signal again when we look at that same spot in the sky. This hypothesis, sometimes called the Bracewell probe hypothesis after the radio astronomer Ronald Bracewell, who first proposed the idea in 1960, suggests that direct exploration using robotic probes might be more common than radio communication. After all, a probe can gather information, adapt its mission, and respond to what it finds in ways a simple radio transmission cannot. We've sent our own probes, the Pioneer and Voyager spacecraft, beyond our solar system. Could another civilization have done the same, and could we have briefly detected one of their probes? There's also the disturbing possibility that the WOW signal was something like a warning, a broadcast telling civilizations not to reveal themselves, to stay quiet, to avoid detection. This ties into a concept called the dark forest hypothesis, proposed by the science fiction author Liu Cixin, but taken seriously by some scientists as a possible explanation for the Fermi paradox. The idea is that the universe might be dangerous, that civilizations hide from each other because revealing your location could attract attention from hostile civilizations with superior technology. In this grim scenario, the galaxy is like a dark forest where predators hunt. Any civilization that makes noise, that broadcasts radio signals or otherwise reveals its presence, risks being found and potentially destroyed. A benevolent civilization that had learned this lesson might send out warnings, brief transmissions telling younger civilizations to be quiet, to stop broadcasting, to hide before it's too late. Could the WOW signal have been such a warning? We have no way to know because it wasn't modulated in a way that could carry complex information like language or images. It was just a carrier wave, a tone. But the very existence of the signal, its strength and its brevity, might be the message. We can hear you, others can hear you, be careful. On a more optimistic note, Some researchers have speculated that the WOW signal might have been an invitation, a first contact protocol, a signal designed to say, "We're here, we're listening, if you want to talk, here's how." In this scenario, the signal's frequency, right at the hydrogen line, was a way of establishing common ground, proving that whoever sent it understands basic physics and astronomy. The next step would be for us to respond, to broadcast a signal back in that direction, perhaps at a harmonic frequency or with some modulation that proves we understand mathematics or physics, establishing that we're intelligent and capable of communication. If we respond appropriately, the thinking goes, they might respond back, initiating an exchange. This is why some SETI researchers advocated for and organized the 2012 transmission from Arecibo, the response sent toward the WOW signal's coordinates. It was an attempt to say, "We heard you, we're here, let's talk." Whether anyone is listening, whether anyone will respond, we won't know for decades. The response would have to travel the distance to the source, perhaps dozens of light years, and then their reply would have to travel back. We might be waiting until the 22nd century or beyond to know if that response made any difference. Let's consider the emotional and philosophical impact of the WOW signal on those who've studied it, on the SETI community, and on humanity in general. For researchers like Jerry Emmon, John Krauss who built Big Ear, and others involved in the search for extraterrestrial intelligence, the WOW signal represents both their greatest success and their greatest frustration. It's the thing they were looking for, a signal that appears to be exactly what SETI hopes to find, but it's also maddeningly incomplete, a mystery they couldn't solve, a question without an answer. Imagine spending your career searching for something, finding evidence that seems to suggest you've succeeded, but being unable to prove it, unable to satisfy the scientific standards of reproducibility and verification. That's the burden the WOW signal places on SETI researchers. It tantalizes them. It keeps them searching. It proves that if you look long enough, you might find something extraordinary. But it also demonstrates how difficult this search is, how easy it is for something profound to slip through our fingers, to appear once and vanish before we can understand what we've seen. For the broader public, the WOW signal serves a different purpose. It makes the search for extraterrestrial intelligence real and immediate. It's not just a theoretical exercise or a science fiction fantasy. It's something that actually happened, a moment in history when we might have detected aliens. That computer printout with the red circle and the word "WOW" is a tangible piece of evidence that the universe might have spoken to us. You can see it. It's real. And that reality makes people think about the bigger questions. Are we alone? What does it mean if we're not? How would contact with an alien civilization change humanity? These aren't abstract philosophical questions anymore. They're questions with real-world relevance because of the WOW signal. It makes people look at the night sky differently, with a sense that maybe, just maybe, someone is looking back. Philosophically, the WOW signal embodies a fundamental aspect of the human condition, our relationship with uncertainty. We are a species that craves answers. We want to know things definitively. We build science, religion, philosophy, all these systems of understanding, because not knowing troubles us. But the universe doesn't always provide clear answers. Sometimes it gives us ambiguity, mystery, questions we can't resolve. The WOW signal is a perfect example. We have evidence, real data, but we can't interpret it with certainty. It could be aliens. It could be something mundane. We simply don't know, and we may never know. How we respond to that uncertainty says something about us. Do we dismiss it, preferring the comfort of skepticism? Do we believe it's aliens despite the lack of proof, preferring the excitement of possibility? Or do we sit with the uncertainty, accepting that some questions don't have answers, that mystery is part of existence, that not knowing is okay? Your answer to that question reveals something about your worldview, about how you relate to the unknown. The technology that might finally solve the mystery of the WOW signal is being developed right now. The Square Kilometre Array, or SKA, is an international project to build the world's largest radio telescope, with a total collecting area of 1 square kilometer, 50 times more sensitive than any existing radio telescope. When completed, the SKA will be able to detect signals far weaker than what Big Ear could detect. It could potentially hear signals from civilizations thousands of light years away. It will continuously monitor vast regions of the sky, making it far less likely that a brief signal would be missed. If the WOW signal or something like it appears again, the SKA will likely detect it. Moreover, the SKA's data processing capabilities will allow for real-time analysis and immediate follow-up, addressing one of the main frustrations from the original WOW signal detection. We won't have to wait days to realize we've seen something interesting. We'll know immediately, and we can point other telescopes at the source within minutes. There are also advances in artificial intelligence and machine learning that are being applied to SETI. The amount of data modern radio telescopes produce is staggering, far more than human researchers could analyze manually. Machine learning algorithms can be trained to recognize patterns, to identify signals that stand out from noise, to classify different types of radio emissions automatically. These systems can process billions of signals per day, looking for the needle in the cosmic haystack. Several SETI projects are already using these techniques, and they're finding interesting signals that might have been missed by traditional analysis methods. None have proven to be alien transmissions yet, but the technology is improving rapidly. It's possible that the WOW signal, if it appeared today with modern analysis tools, would be understood better, characterized more completely, perhaps even decoded if it contained modulated information. Space-based radio telescopes are another promising development. One of the challenges of radio astronomy from Earth is interference. We're surrounded by radio signals from satellites, cell phones, Wi-Fi routers, radar systems, all manner of human technology that creates noise in the radio spectrum. Getting away from that noise would make detection of weak signals much easier. A radio telescope on the far side of the moon, shielded from Earth's radio emissions by thousands of miles of solid rock, could listen to the universe with unprecedented clarity. NASA and other space agencies have studied concepts for such telescopes. They're technically challenging and expensive, but they're feasible with current or near-future technology. A radio telescope on the far side of the moon could potentially detect signals that would be completely drowned out by terrestrial interference if observed from Earth. It could be the instrument that finally hears the WOW signal again or detects something even more compelling. But let's be realistic about the challenges. Even with better technology, the search for extraterrestrial intelligence is looking for something incredibly rare in an incomprehensibly large search space. The galaxy is vast. Radio signals weaken with distance. Civilizations, if they exist, might not be broadcasting. They might exist at a different time than us, having risen and fallen millions of years before Earth even formed, or yet to emerge millions of years in the future. The window during which any two civilizations are both technologically capable and searching for each other might be vanishingly small. Carl Sagan once calculated that if civilizations typically last only a few thousand years, and if they're scattered across the galaxy, the chances of two civilizations existing simultaneously and being close enough to communicate would be extremely small. We might be looking for neighbors in a cosmic ghost town, calling out to civilizations that are already extinct or yet to be born. This brings us back to the profound loneliness at the heart of the WOW signal story. Whether it was aliens or not, it represents our isolation. We are a species alone on a small planet, looking out into a universe of unimaginable size, hoping desperately that someone is out there, that we're not the only ones, that consciousness and intelligence and the ability to wonder about existence aren't unique to us. The WOW signal gave us a moment of hope, 72 seconds when it seemed like maybe, just maybe, someone had heard us or wanted us to hear them. And then silence. The silence has lasted more than 40 years now. That silence is heavy with meaning. It reminds us how rare and precious intelligence might be, how vast and empty the universe appears, how unlikely connection is across the cosmic distances. It makes us appreciate what we have here on Earth, this world where we've emerged, where we've built civilizations, where we've learned to ask questions about our place in the cosmos. Maybe we're the first. Maybe we're the last. Maybe we're alone. Or maybe we're just not looking in the right way, not listening long enough, not patient enough for the timescales that interstellar communication requires. There's something beautifully human about the WOW signal story. It's a story about curiosity, about the drive to explore and understand, about hope persisting in the face of uncertainty. Jerry Emmon didn't have to spend his time reviewing radio telescope data. John Krause didn't have to build Big Ear. SETI researchers don't have to dedicate their careers to searching for signals we might never find. They do it because humans are curious. We want to know. We want to understand. We want to reach beyond ourselves, beyond our world, beyond our limitations. The WOW signal represents that impulse in its purest form. For 72 seconds, we reached out and possibly, just possibly, touched something beyond ourselves. That moment, whether it was aliens or not, represents the best of what we can be. Seekers of knowledge, explorers of the unknown, a species that looks at the infinite cosmos and asks questions rather than turning away in fear or indifference. As we draw toward the end of this exploration, let's consider what the future might hold. Suppose, someday, we do find definitive evidence of extraterrestrial intelligence. Suppose we detect a signal that repeats, that we can study, that clearly comes from an alien civilization. How would that change us? The discovery would be the most significant in human history, more important than fire, the wheel, agriculture, or any technological innovation. It would fundamentally alter our understanding of our place in the universe. We would know, with certainty, that we're not alone. That knowledge would change religion, philosophy, science, politics, everything about how we see ourselves. Some people would be thrilled. Some would be terrified. Some would deny it, unable to accept something that challenges deeply held beliefs. But eventually, over time, it would become part of our worldview, part of how we understand reality. We would be one species among many, one civilization in a cosmos full of civilizations. Or suppose we search for another century, another 1,000 years, and find nothing. Suppose the silence continues, unbroken, no matter how sophisticated our instruments become, no matter how carefully we search. What would that mean? It might mean we truly are alone, that intelligence is so rare, so improbable, that it's happened only once in the observable universe. That would make us incredibly precious and incredibly lonely. It would mean that everything we've ever known, everyone we've ever loved, every idea and creation and achievement of humanity, exists in isolation, unique in all of space and time. That realization would be both humbling and terrifying. It would place an enormous responsibility on us to preserve what we have, to not destroy ourselves. Because if we're the only ones, our extinction would mean the extinction of consciousness itself, at least in this corner of the universe. The stakes couldn't be higher. The WOW signal sits at the boundary between these two futures. It might have been our first contact, a message we failed to recognize or respond to adequately. Or it might have been nothing, a fluke, a reminder that the universe is full of things we don't understand, but that don't necessarily mean we're not alone. We exist in that uncertainty, in the space between knowing and not knowing, between contact and isolation. And perhaps that's where we'll always be. Perhaps the universe is designed to give us just enough evidence to hope, but never enough to know for certain. Perhaps mystery is fundamental to existence, and the WOW signal is the universe's way of keeping us wondering, searching, reaching for answers we might never fully grasp. What I want you to take from this story is not a definitive answer about what the WOW signal was. I can't give you that answer because it doesn't exist. Not yet, maybe not ever. What I want you to take is an appreciation for the magnitude of the question, for the courage it takes to search for answers when success seems unlikely, for the beauty of human curiosity that drives us to point telescopes at the sky and listen for voices in the cosmic static. The WOW signal matters not because it proves anything, but because it represents something essential about who we are as a species. We're the ones who ask, what if? We're the ones who wonder. We're the ones who hear a signal from space and write, "Wow," in the margin because we understand, in that moment, that we might be witnessing something extraordinary. On a clear night, go outside and look up at the stars. Think about the fact that the light you're seeing left those stars years, decades, centuries ago. Think about the possibility that around one of those stars, a planet orbits, and on that planet, someone might be looking up at their night sky, seeing our sun as just another distant point of light, wondering the same things we wonder. Think about the wow signal, that 72-second moment when the universe might have spoken, when we might have heard proof that we're not alone. Think about all the radio waves crossing the cosmos right now, signals from civilizations we can't see, conversations we can't hear, messages crossing the light years in the darkness between stars. Or think about the possibility that there are no such signals, that the universe is silent, that we're alone with our questions and our wonder. Either possibility is profound. Either possibility should fill you with awe. The WOW signal's greatest legacy might not be the data it provided or the scientific papers it inspired. Its greatest legacy might be the way it makes us think about ourselves and our place in the cosmos. It challenges us to imagine a universe more complex, more populated, more wondrous than the empty void we might have assumed. It reminds us that we've barely begun to explore, that our knowledge is incomplete, that mysteries remain and might always remain. It tells us to keep looking, keep listening, keep wondering. Because even if we never hear another signal like it, even if the WOW signal remains forever unexplained, the act of searching, the commitment to asking questions and seeking answers, is what defines us as human. We are the species that looks at the stars and wonders. We are the species that builds radio telescopes and listens for whispers across the void. We are the species that takes 72 seconds of data and asks the biggest question we can imagine. Are we alone? On August 15, 1977, for exactly 72 seconds, something extraordinary happened. We might have heard aliens. We might have detected a comet or some natural phenomenon we don't understand. We might have glimpsed something that will remain forever mysterious. But whatever it was, it reminded us that the universe is vast and strange and full of possibilities. It reminded us that there are questions worth asking even when answers are elusive. It reminded us that we're part of something bigger than ourselves, part of a cosmos that might be teeming with life and intelligence, or might be empty except for us, but either way is worthy of our attention, our study, our wonder. The WOW signal was, and remains, a moment when the universe captured our imagination and refuses to let go. And maybe that's exactly what we needed. Maybe that moment of uncertainty, of possibility, of profound mystery, is what keeps us reaching for the stars, keeps us searching, keeps us hoping that someday, somehow, we'll hear that signal again, and this time we'll understand what it means, where it came from, and who sent it. Until then, we listen, we search, we wonder, and we remember that night in August when someone or something might have said hello, and we wrote "wow" in response, beginning a conversation that continues in silence, waiting for the next word to be spoken across the infinite dark.